Algebra 1 students, welcome to your 3.4 notes, solving multi-step inequalities. We're going to take some of the things that we've done in previous sections from Chapter 3 and just stretch them out a little bit to add a few things to our repertoire of inequality solving. So here we go. Let's go ahead and solve the first one here. It says 3x minus 6 is greater than 18. If you think of this inequality as being the same as an equal sign, we would know, okay, well, we need to add 6 to each side. So we would have 3x, keep the inequality as it is, greater than 24. Then we can divide both sides of the inequality by 3. And we would know that x is greater than 8. Alright, let's take a look at the next one, number 2. We have ends on both sides. Now what I know is that with inequalities, we probably prefer having our variable on the left-hand side. So negative 7n plus n is going to give me minus 6n less than or equal to, and we'll have a 21 over here. Subtract 5 from each side. So we know negative 6n is less than 16, and then we've got to divide by negative 6. Now remember, when you divide by a negative, this is going back to our last lesson, you've got to flip that inequality. So n is greater than negative 8/3. Alright, why don't you guys give it a shot on number 3. Pause the video, see how your answer compares to mine. Alright, welcome back. You can see my work on number 3. I subtracted 6 from each side and then divided by negative 2. Note that when I divided by negative 2, that inequality went from less than equal to, that you see right there, to over here being greater than equal to. Now, the variable is on the right, so sometimes it's easier for us to think of it with the variable on the left. So when you do that again, you have to switch that inequality. It's like if you're reading it backwards. If I read this one backwards, it would say n is less than or equal to 8. You kind of have to read that sign backwards to make that work. Alright, let's crank up the difficulty just a notch. A little more work to do on this one. So we'll say 22 is greater than or equal to. I need to distribute the 5, so we'll have a 10y plus 15. That minus 3y still hanging out back there. You might be able to do this in fewer steps than I'm doing, but I think it's safest if we go ahead and do this in as many steps as we need to. So 10y minus 3y would give me a 7y plus 15. Now I can subtract that 15 safely. 7 greater than or equal to 7y. Of course, that means we need to divide by 7. So 1 is greater than or equal to y. Again, with inequalities especially, we much prefer that our variable be on the left. So we could switch it to look like that. Y less than or equal to 1. Alright, same idea. Let's move variables to the left this time on number 5. So I'm going to subtract 3x. So I'll have negative 4x plus 2 is less than, and all that's left on the right side is a negative 6. Subtract 2. And again, we need to divide by a negative. We've seen this before, and we know when you divide by a negative, you've got to switch the inequality. So x is greater than 2. Again, go ahead and pause the video so that you can compare your answer to mine. Okay, now you can see my answer on number 6. X is less than negative 8/3. The key step on this one, in my opinion, is the distribution of the negative. That's something we've struggled with a bit. Make sure that negative sign here doesn't just go to 3x, but that it also goes to 5. That's why you'll see 3 minus 3x minus 5. We can combine like terms. 3 minus 5 is negative 2. Then you add 2 and then divide by negative 3 on both sides. And again, remember, when you divide by a negative or multiply by a negative, you got to switch the inequality. So it's x is less than negative 8/3. And moving on, you can see on questions 7 through 9, they look really similar to what we've done in the last several questions, the first 6. However, based on the instructions, you could probably imagine that we might be running into something a little different before we get through this. So let's see what happens. First thing I'm going to do is distribute the 2 on this first problem, and I'll have 6w plus 6. Now, as you know, we really want to get all the w's to one side of the inequality. What's going on here? And I see that 5 is greater than 6. Now, I don't know much, but one thing that I do know is that 5 is never greater than 6. So I can just simply write no solution. That can't happen, folks. All right, let's take a look at the next one. Same idea, a little distribution. So negative 5r plus 15 is greater than or equal to, and we'll have negative 5r plus 10. If we add 5r to each side, we'll be in the same scenario we were in a minute ago. Well, sort of the same. And we'll have 15 greater than or equal to 10. Now again, no variables, so I can't really solve this for r, but I can look at it this way. When is 15 greater than 10? Always. So that's all real numbers. All right, one last time, go ahead and pause the video and do this problem number 9 on your own. As you can see on number 9, I got no solution. Just to kind of clarify what this means, when we get no solution, that means it doesn't matter what value you plug in for n, this simply cannot happen. 2 times n minus 3 can never be less than negative 13 plus 2n. It's impossible. By the same token, when we get all real numbers, that means it doesn't matter what value we plug in. So when we look back, let's say at number 8, it wouldn't matter what value we plugged in for r. This would always be true. Just something to keep in mind. Again, it's not every problem isn't going to be one of those, but you will run into it from time to time. All right, one last problem, a little application for you to finish things off. A family rents a boat for the day while on vacation. Sounds good to me. The rental rate is $500 for the first 2 hours and $50 for each additional half hour. They can spend up to $700, right, and solve an inequality to represent how many hours the family can be on the boat. Well, one thing we need to do is define variables. So I'm going to say h represents number of hours. And that's, of course, implying hours that the boat is in use. So what we know is it's $500 for the first 2 hours plus $50 for each additional half hour. Now, since I've got h written in hours, I'm actually going to think of that $50 per half hour as being $100 per hour. So 100 times h. However, don't forget that the first 2 hours were already covered with this $500. So we're going to go h minus 2. And the family can spend $700, so we're going to go less than or equal to $700. They could, of course, spend $600 and be just fine. They could spend $700 and be fine, but not $701. All right, so it should look something like this. 100 times n minus 2, or h minus 2, I should say, would probably be the part that would be most confusing in this, but essentially the minus 2 is taking away the first 2 hours. This is 100 rather than 50 because this is $50 per half hour. We're saying h represents hours. All right, let's do a little work here to simplify. So 100h minus 200 less than or equal to 700. I'll go ahead and combine like terms, so I'll have 100h plus 300 is less than or equal to 700. We can subtract. So 100h is less than or equal to 400. And finally, one step of division, and we know h is less than or equal to 4. So what we would say then to kind of finish this problem up, we need to say something to the effect of the family can rent the boat for up to 4 hours. All right. I hope this lesson works for you. I think it's a good one, and I think it has some pretty cool applications. So good luck on your studies. Come to class ready to roll. Have a great day.